live. Hello, Kagglers. This may be at a different time for you than it has been in the past because here in the US, well, I shouldn't say that, not all of the US. Here in Washington State, we did daylight savings time. And all right, looks like that's good. So waiting for YouTube to catch up. And so the time might have shifted between me and you. And I just realized that this morning as I was setting up. Otherwise, I would have tweeted about it earlier. But hello, welcome. We are going to be continuing with the paper that we started last week. And I'm going to start with an overview. So if you missed last week, don't worry. Gonna get a little sip of coffee. I'm still not over this mug. It's so cute. And for those of you in different parts of the world, it is 9:02 a.m. for me, so a very reasonable time to be drinking coffee. So this paper was at ACL 2019 this year in Florence. I keep saying Venice. It is, in fact, Florence. Hi, Manoy, maybe? Ooh, is that my hair? Yep. Get back in there. And the idea of the paper is that it is a system that will, when it makes mistakes and gets correction from a human, so here's a little example here, will take those corrections and add them to the bot's available sort of bank of responses. And the things that are new about this system is it predicts the satisfaction of the person who's talking to the bot in real time. So you can see here there's this satisfaction score, and then when it predicts the satisfaction is low, it asks for a correction explicitly, and then the correction is incorporated into the bot's behavior going forward. So that's the idea behind the system. And it is a chit-chat bot, so it's just sort of going back and forth. It's not for a specific purpose. And I'm trying to remember where we left off. Hello, Srini and Shaitan. Welcome. All right. And so this is, again, just getting back up to speed. So this is the system itself. So the original training data is based on a human-human dialogue data set. And they also had human ratings of satisfaction. So the satisfaction score that's being applied here is based on is trained based on human raters' satisfaction levels. And then that is taken for the first pass. And given X, which is the context of the conversation, so everything that's happened previously in the conversation, the model generates Y hat, which is the potential next response, the predicted next response, S hat, which is the predicted satisfaction level, and then F hat, which I forget what F hat is. I would search for F, but I don't think it would find it, and I don't know how to type hat. What's F hat? Feedback? I think it's trying to predict what the feedback will be. Yeah, and I think we hadn't quite gotten to that part of the paper yet, so it's also predicting the feedback. And if the satisfaction rating is underneath, based on a threshold that is set by the researchers, if the satisfaction is above that, then it's like, great, that was a good interaction. If the satisfaction is below that, then the human interlocutor is asked, hey, what could I have done better? The human gives feedback. And I think this X here may be incorrect because from what I remember, it is the once a feedback turn is had, the previous context of the conversation is discarded, is my understanding, if I'm remembering correctly. So this particular arrow may be incorrect. But whichever way, the dialogue between the human and the bot and the feedback feedback both get folded back into the training data, and then the whole system is retrained. Jamie says on Mac, to get the hat, it's Alt-I and then the letter you want. I'm actually on Windows, and I don't know if that will work. Let's see. Alt-I-Y. Yeah, no, it doesn't seem to work, unfortunately. But thanks for the tip. For those of you Mac users out there, that is helpful to know. All right. And I believe we read about task 1 in the dialogue. And this Parl AI platform is a task specific. Actually, let's just go to it. Here we go. A unified platform for sharing, training, and evaluating dialogue models across many tasks. So this is specific to dialogue modeling, chatbot, that sort of thing. Chatbots and that sort of thing. Chit chat is just like asking, answering questions, and having a conversation. And then visual question answering is like, here's an image. How many giraffes are there? To quote a famous example. Ion says, does anything in this paper suggest that this method can only be used for chit chat? Is there any scope for adapting it to a question answer system? That's a great question. We haven't finished the paper yet, but I think you could absolutely use the same approach for question answering, but the way that you update the model will probably be a little bit more sophisticated, is my guess. All right, so, and these are the types of answers, those types of feedback you can get from users that they discovered or that they found users were doing. So one is that the bot's like, hey, what should I have said? And then the person says exactly the thing that the bot should have said. So verbatim, meaning word for word. Suggestion is you could have done something like this. So the exact utterance and then sort of like more information about it. Instruction just sort of like, this is the class what the answer should have been. And then options is when the, I keep wanting to say interlocutor. Interlocutor just means a conversational partner, but the person interacting with the chit-chat system gave multiple things that it could have been. Hello, Covis. Welcome, welcome. So the first task is to create good dialogue. And we still don't know what FHAT is, and that's okay. And then the second task is to predict satisfaction levels. And this was based on this was originally trained based on a human rater data set. And then the third task, I think we're going to pick up here, even though I think we read this last time, was feedback. The objective of the feedback auxiliary task is to predict the feedback that will be given by the speaking partner when the agent believes it has made a mistake and asks for help. Examples take the form of XF pairs, where X is the same context as the other two tasks, and F is the feedback utterance. So predicting the type of feedback that you'll get or the exact feedback utterance. Training data for this task is collected during deployment. Whenever a user's estimated satisfaction is below a specified threshold, the chatbot responds, excuse me. Excuse me, goodness. Whenever a user's estimated satisfaction is below the specified threshold, the chatbot responds, oops, sorry, what should I have said instead? A new example for the feedback task is then extracted using the context up to but not including the turn where the agent made the poor response as X and the user's response as F. At that point, to continue the conversation during deployment, the bot's history is reset, that's what I was talking about, and the bot instructs the user to continue asking for a new topic. Examples of feedback responses are shown in Table 2. So it's predicting feedback from the set of feedback instances that it has already seen, is what I'm getting from here. Thank you, Covis. Okay, model architecture. And I believe we actually read this previously. Yeah, I don't want to go through that again because it was, as I remember, fairly standard. So section 5, experimental results. Throughout this section, we use the ranking metric hits at x over y, or the fraction of the time that the correct candidate response was ranked in the top x out of y available candidates. Accuracy is another name for hits at 1 over y. Okay, so what they're saying is that we are judging our system based on whether the correct response is in, let's say, 3 out of 5. Out of the 5 available candidates, if the correct response was in the top 3, then you would count that as a hit, and if it wasn't, you would count it as a miss. And accuracy is the number of times that the correct response is the first response predicted out of all of the possible candidates. Okay. Statistical significance for improvement over baselines is assessed with a 2-sample one-tailed t-test. I guess it's one-tailed because they are coming in with the assumption that their system is going to do better than other baselines, but there's, I'm trying to think if I would do this as a one-tailed or a two-tailed test. I guess if you have a strong assumption that your system is going to be better, then it makes sense to be one-tailed. Anyway, benefiting from deployment examples. So this is how they're actually looping in the feedback they're getting after deployment. Our main result, reported in Table 3, is that utilizing the deployment examples improves accuracy on the dialogue task regardless of the number of available supervised human-human dialogue examples. The boost in quality is naturally most pronounced when the human-human dialogue training set is small, i.e. where the learning curve is steepest, yielding an increase of up to 9.4 accuracy points, a 31% improvement. Improve the deployment examples. Okay, so basically they're saying if you use the examples of the deployed system interacting with a human, then you get better accuracy overall. Although accuracy is, they don't say what the X and Y is here, so it could be like it's in the top 10 out of 100 possible results. The Answer to Life says, what's dialogue? So dialogue is language interactions in which there are two people, basically. So a monologue would be one person talking to themselves. A dialogue is two people talking back and forth. Although usually people can also use dialogue to mean multiple people talking together. So, good question. Okay, so they're saying that adding their examples gets better performance overall, which is not surprising on small data sets because you're increasing the amount of available data significantly. Metalink says, one failed because they are concerned with only one direction. Interesting. I'm assuming you're... Oh, one-tailed. Yes, okay. I was like, I don't know about the failing, but... yeah, but you'd also want to know if your system was worse than the other system. I don't know. The Answer to Life says, oh, right, the normal definition was in machine learning mode, forgot English. That's fine. Because a lot of regular English words like, I don't know, gate or door may not mean the same thing in a machine learning context. However, even when the entire Persona Chat dataset of 131K examples is used, a much larger dataset than what is available for most dialogue tasks, adding deployment examples is still able to provide an additional 1.6 points of accuracy on what is otherwise a very flat region of the learning curve. So they're saying even if there's a lot of data, adding more data from a deployment still helps. I don't know that that's surprising in any way to me. Maybe I'm missing something here that's underlying these observations. It is interesting to note that the two types of deployment examples appear to provide complementary signal, with models performing best when they use both example types, despite them coming from the same conversations. We also calculated hit rates with 10,000 candidates instead of 20, a setup more similar to the interactive setting where there may be many candidates that could be valid responses. Okay, and then what's the X then? So they're looking at 10,000 possible candidate responses, and they're saying that they have a success if their response is in the top question mark of those 10,000. In that setting, models trained with the deployment examples continue to outperform their HH only HH is human, HB is human bot, only counterpoints by significant margins. See Appendix B. Oh, okay, so I know why they're saying that. So previous work had found that if you try to augment a human-human dialogue data set with bot-bot data dialogue, so just two chatbots talking to each other and generating text that way, that you get worse performance over time. So they're saying that even though only one of the interlocutors is a human, it still improves our overall performance on this task, which... Okay, so given the literature, I think that makes sense that they would say that and be like, this is cool, but given the fact that there's still a human involved, which is like the point, like the hard thing is to get the human to do the thing. I don't know if any of you have ever run human subjects experiments, but can be tricky. Let me put it that way. It's hard to get people to come to a lab and actually do something, or even just do your task online. So cool results. I don't know that it's super groundbreaking, but also that's not like the point of the thing. Metalink says we only know to know whether the two samples are different or not. This is the null hypothesis. Okay, that makes sense. Excuse me. I'm pretty sure at this point that I have indoor allergies and I have an air filter on the way that will hopefully help, and then I'll be less sniffy is the plan. Okay, so this is table 3, I hope. Yep. Accuracy at hits at 1 through 20. So is the top one result is... So out of the top 20 results, is the correct result the first one? On the dialogue tasks hidden test set by number of human-human dialogue, human-bot dialogue, and feedback examples, averaged over 20 runs with standard deviations in parentheses. For each column, the model used all 3 data types, last row, is significantly better than all the others, and the best model using only one type of self-feeding, feedback examples, or human-bot dialogue examples is better than the supervised baseline in the first row. I do really like that they show standard deviation in performance, because generally folks don't, especially with very large models, because it's very expensive to train enough models to get a good sense of the variation. But I quite like that. Okay, so here is the baseline here where we're just using the given data, and we have an accuracy. So out of the top 20 candidates, did we get the correct candidate the first time as our first one? It reaches a maximum of 44.7%. When we start adding dialogue information, so augmenting the data set with the human-bot dialogue, you see additional improvements, it looks like, across the board, and that those improvements get larger as you increase the amount of human-bot dialogue. And it doesn't seem to be consistently increasing or decreasing the variance in the model performance either. And then when you add feedback, you see an even larger increase in the model performance, which I think makes sense to me because this is going to target places where the model is having poor performance already. And so if you can imagine like a large latent space, ideally the feedback is going to be filling in areas where you have very sparse representations and increasing the model's ability to handle that. And then when you add both types of data, you see an even larger increase over the base data. Although this is almost doubling the total amount of data available to the model, because 60K plus 60K is 120, which is roughly equal to 131K, and adding an additional 120 examples is worth 2 points of accuracy, almost 2 points of accuracy. Also, something to notice is that the best model is still wrong about half the time. So if you're using this system, you'd have to give it feedback every other interaction, assuming that you're using, that you're not just hitting the interactions that are very common and it has good performance on. And that seems frustrating. Reading the caption here. Accuracy hits at 1/20 on the dialogue tasks hidden test set by the number of human-human dialogue. Oh, we read all that. Yeah. And then they did hypothesis testing that their model is better than the supervised baseline and found that it is. All right. Alexi says, I have a general question as a beginner data scientist. In what way does reading papers help your data science career? The question is very broad, but I'm curious about the motivation to read papers. Thanks. I think the clearest reason to read papers as a data scientist is because the field of machine learning and NLP are moving very quickly. So learning how to read papers, which is generally the first way, ideally, the first way that a new research finding is shared, as opposed to, say, a news article, can help you stay on top of the field. I don't think you have to necessarily read a ton of papers, but it can be helpful for understanding what the current state of the art is. Do I think any data scientist needs to read papers? Not necessarily, but it's good, enrichment and professional development. All right. On average, we found that adding 20K feedback examples benefited the agent about as much as 60K HB dialogue examples. So you need 3 times as many successful interactions as unsuccessful interactions with explicit feedback to get the same degree of improvement. This is somewhat surprising given the fact that nearly half of the feedback responses would not even be reasonable requests if used verbatim in a conversation, instead being a list of options, a description of responses, etc., as shown in Table 2. Oh, that's right. They just took the raw text of the feedback and then looped it back into the training example, so you could just get the raw text of the feedback out, as I remember. And there may be something in their system that prevents that they didn't mention, or they did mention and I forgot. Both very possible. Nevertheless, the tasks are related enough that the dialogue task benefits from the MTL model's improved skills on the feedback tasks. MTL model. I don't remember what that is. And whereas HB dialogue examples are based on conversations where the user appears to already be satisfied with the agent's responses, each feedback example corresponds to a mistake made by the model, giving the latter dataset a more active role in improving quality. Interestingly, our best performing model, which achieves 46.3% accuracy, on dialogue, soars 68.4 on feedback, suggesting that the auxiliary task is a simpler task overall. Interesting. And scrolling back down here, our baseline chatbot collected approximately 1 feedback example for every 2 human bot dialogue examples. Yikes. But this ratio will vary by application based on the task's difficulty, satisfaction thresholds, and current model quality. Yeah, but can you imagine? That would be so frustrating. You're trying to, reserve a rental car or something, and every 2 turns the bot's like, I went to Peru, and you're like, no, that's not right. And you have to correct it and be like, I actually asked what colors of Chevy Volts you have, or whatever your question was. Yeah, not amazing UX probably, but again, this is a prototype system. I don't think anyone's putting this into into their products as is. When extracting human bot dialogue examples, we ignore human responses that the agent classifies as expressing dissatisfaction, since these turns do not represent typical conversation flow. Including these responses in the 60K human bot dialogue dataset increased hits at 1/20 by 1.2 points and 0.6 points when adding to 20K and 131K human-human dialogue examples, respectively. Okay, so when you add 60 so when you include in the 60K human bot dialogue dataset the poor turns where the bot did poorly, you decrease your accuracy by 1.2 points in the 20K human-human dialogue and 0.6 points in the 131K human-human dialogue. So basically they're saying when you include bad turns where the conversation doesn't go well, it decreases performance, which I think is pretty reasonable and again aligns with the earlier results that they talked about. IAM says, can you explain what the auxiliary task is? So there's actually 3 tasks at once here. One is generating the next turn of dialogue. One is predicting how satisfied the user will be. And the third is predicting the feedback that a user will give. And the auxiliary task that they were referring to there was predicting the feedback that a user will give. So this is multitask learning, where they're trying to optimize for all 3 of those things at the same time. Good question. We also explored using chatbot responses with favorable satisfaction scores as new training examples, but found that our models performed better without them. Interesting. Okay, see Appendix D for details. I think we will if we get to the end of this. We also found that fresher feedback results in bigger gains. We compared 2 models trained on 20K human-human dialogue examples and 40K feedback examples. The first collected all 40K feedback examples at once, whereas the first was retrained with its first 20K feedback examples before collecting the remaining 20K. So the first one, they just saved all the feedback and then retrained. The second one, they saved a bunch of feedback, retrained, redeployed, got additional feedback. So this is a little bit more active. It's not quite online. It's not updating the bot every interaction, because that would be expensive. But it's sort of doing it in multiple batches instead of a single batch. While the absolute improvement of the second model over the first was small, it was statistically significant and reduced the gaps to a model trained on fully supervised human-human examples by 17%, while modifying only 33% of the training data. This improvement makes sense intuitively, since new feedback examples are collected based on failure modes of the current model, making them potentially more efficient in a manner similar to new training examples selected via active learning. It also suggests that the gains we observe in Table 3 might be further improved by A, collecting feedback examples specific to each model, rather than using the same 60K feedback examples for all models, and B, more frequently retraining the MTL model, e.g. every 5K examples instead of every 20K, or updating it in an online manner. We leave further exploration of this observation for future work. So what they're saying is, if we'd listened to the feedback and then done something about it, probably the model would have gotten much better over time, is their guess. And we haven't gotten to Table 4 yet. The same experiment, repeated for HB dialogue examples, found that fresher HB examples were no more valuable than stale ones, matching our intuition that HB dialogue examples are less targeted at current model failure modes than feedback ones. So just getting more data about things that work well is not as helpful as getting specific feedback on things that don't work well. 5.2, predicting user satisfaction. For maximum efficiency, we aim to ask for feedback when it will most benefit our model. The approach we chose, classifying the tone of partner responses, takes advantage of the fact that it is easier to recognize that a mistake has already been made. oh gosh, excuse me, than it is to avoid making that mistake. Or in other words, sentiment classification is generally an easier task than next utterance prediction. True. At least in my experience. We compare this to the approach of asking for feedback whenever a model is most uncertain what to say next. So instead of predicting, instead of being like, oh, they didn't like that, I should ask for feedback, being like, I don't know what to say, I'm going to ask for feedback. This approach acts on the assumption that the model will be least confident when it is about to make a mistake, which we find very frequently to not be the case. Not only is it difficult to recognize one's own mistakes, but also there are often multiple valid responses to a given context, e.g., yes, I love seafood, or yuck, fish is gross. A lack of certainty about which to use does not necessarily suggest a poor model. That makes sense if you're trying to, you don't want to necessarily, what am I saying here? There's beautiful infinite complexity in human language, and just because and the fact that there's not always one right thing to say next in a conversation does not mean that that makes your model poor, if that makes sense. I see what they're saying here. Coffee. Table 4 reports the maximum F1 scores achieved by each method on the satisfaction test set. So this is one that they collected themselves. For the model uncertainty approach, we tested two variants. A, predict a mistake when the confidence in the top-rated response is below some threshold T, and predict a mistake when the gap between the top two rated responses is below the threshold T. So I'm not sure about the top one, or I think the top two are both pretty likely, or similarly likely, not necessarily very likely. We used the best performing standalone dialogue model, one trained on the full 131K training examples, for assessing uncertainty and tuned the thresholds to achieve maximum F1 score. For the user satisfaction approach, we trained our dialogue agent on just the satisfaction task. Wait. Oh, okay. So tuning on getting the hits. Because the satisfaction is a scalar score, so F1 wouldn't make sense for that, but they mean for the generation of the next turn of dialogue. Okay. I figured out the thing that I was confusing myself with. Finally, we also report the performance of a regular expression-based method, which we used during development based on common ways of expressing dissatisfaction that we observed in our pilot studies. See Appendix X for details. So they also just hand-built a system that's is there a frowny face, or did somebody yell at your system, or something like that. So looking for specific words. As shown by Table 4, even with only 1K training examples, the amount used for the experiments in Section 5.1, the trained classifier significantly outperforms both the uncertainty-based methods and our original regular expression by as much as 0.2 and 0.42 F1 points, respectively. Okay, so let's check Table 4. The maximum F1 score with corresponding precision and recall obtained on the satisfaction test. For the uncertainty models, we also report the maximum F1 score with the constraint the precision must be greater than 0.5. The satisfaction classifier is reported with varying numbers of satisfaction training examples. Oh, that's right. Okay. So I was right. Satisfaction was collected as a scalar score, but they've binned it into satisfied and unsatisfied, which is why this is an F1 classification measure instead of a regression measure. Okay, that makes sense. So this is directly predicting the classification and not the next turn of dialogue. So their baseline is this hand-built regular expressions model that has really good precision, pretty bad recall, and sort of a middling F1. Comparing that to this model based on how confusion, I guess, of the model. So when the top-rated candidate is not highly likely, using those ones, or asking for feedback then, or asking for feedback when there's a big gap between, when there's a small gap between the first and second candidate responses. and it looks like very slightly better performance on when you're just very uncertain about the top one, but both of these are not great. Where on the other hand, looking at this based on the predicted satisfaction score rather than the confusion between candidate answers, we see that that has the best performance, and as you increase the amount of training data, you get a better performance. And this is a very significant gap from the uncertainty examples. So that's interesting. Yeah, based on their explanation, I think that makes sense. I wouldn't necessarily have guessed that right off the bat. But I suppose it is a very large space of potential candidate answers. So you might at times be very uncertain just because there's many things to pick between. All right, section 6, future work. In this work, we learned from dialogue using 2 types of self-feeding: imitation of satisfied user messages and learning from the feedback of unsatisfied users. In actuality, there are even more ways that a model could learn to improve itself. For example, learning which question to ask in a given context to receive the most valuable feedback. One could even use the flexible nature of dialogue to intermix data collection of more than one type, sometimes requesting new feedback examples, other times requesting new satisfaction examples, e.g. asking, "Did my last response make sense?" In this way, a dialogue agent could both improve its dialogue ability and its potential to improve further. We leave exploration of this meta-learning theme to future work. And that's the end of the paper, and then we have references. Okay, let's pop down and look at the appendixes and then talk about the paper a little bit. I'm still not 100% sure what they're predicting in the feedback task. Let me just feedback. Browser feedback. Okay. What are you predicting when you're predicting feedback? Such as verbal cues and scalar rewards, feedback explicitly, request feedback, new feedback examples. There's somewhat other less related ways to use feedback during dialogue learning, scalar, feedback request and cue. What feedback am I about to receive? So I think it's trying to predict the utterance from the feedback. Which I believe what the system is doing is that it has sort of a list of all of the possible utterances it's been exposed to after it's been retrained. And then the feedback prediction is like a task ranking prediction. So trying to rank which response you are most likely to get as feedback. Is that what I'm understanding? Yeah, we rely on the fact that it's not random. There's a learnable relationship. Okay. Ryan says, allowing users to train your model is a bit concerning. Microsoft had their Chatbot that totally went off the rails because of this. Yes, we talked about that very briefly last week. Yeah, we can sort of talk about paper, my reaction to the paper, and then scooch on down. And Ian says, how would you rate this approach in terms of being actually used in real-world settings? I mean, the whole idea of trying to learn more while in deployment and not just their particular method. Yeah. So I think it's possible in theory. I think you need to be extremely, extremely, extremely careful about how you do it. Okay, so first of all, just from a user experience perspective, if every third turn the bot is messing up and asking you for direct feedback, that's awful. That's gosh awful. Don't like that, would not use it. And so that's one part of it. Like, I don't think it's a very effective bot. I realize this is a prototype system. I don't think, I'll go up here so we can, I just want something interesting on the screen so you guys can, and so I can refer to. There we go. We'll get sort of the system dialogue. So the just from a usability standpoint, I don't love that as someone who might use this system. I also don't like that you're offloading a lot of the labor onto humans who are trying to use your system, like end users. It's obviously it's cheaper than trying to pay someone to help with your data set annotations, to do annotations as a bot, interacts with them. But that is like unpaid labor for your presumably commercial product, and you're taking that from the users. Maybe if there was a way that you could opt in or out of giving the bot feedback. So like at the end of every interaction, it's like, would you like to help me learn better and give feedback during the course of our conversation? That might be one way of sort of assuaging my feelings there. So on the one hand, the unpaid labor, the learning from interactions is not awesome. I think it could work, but you'd have to be very mindful about how you did it. And another thing is the fact that they are not, like Ryan brought up, when you release a system that learns from interactions in a completely unprincipled, uncontrolled way, especially a system like this where the generated output is based on just like the list of generated inputs that it's been given, you have the potential to create a system that is abusive, that is using slurs, that is actively homophobic or racist or sexist. So that's what happened with Tay. I don't know if y'all are familiar. That was a chatbot that did this sort of active online learning that Microsoft put on Twitter, and within like a couple of hours, the bot was saying like truly horrific things because it was parroting back what it had. It was parroting back what it had been exposed to. So the fact that they don't recommend any sort of data cleaning, and again, controlled environment, it's a prototype system, so they might have reason to get around it, I guess, just to see if the idea worked. But I would not deploy a system without any sort of abuse detection or prevention. That I think that's my number one problem with this type of system is the potential for abuse. So I'm trying to come up with like a good example, but I also don't want to say anything horrific, and all of the examples I'm coming up with are just like god awful. Yeah, so that's a major concern. You have to have some way of determining when the responses that you're folding back into your system are absolutely inappropriate. I think the multitask learning that also is sort of trying to guess how satisfied the interlocutor is a really cool idea. I do like that. I think that it makes a lot of sense as a second objective. And I believe that they talked about it previously as well. So people who are folding in learning to ask questions, use responses to detect mistakes, correctly assessing, feedback. Yeah, so there's a lot of work on incorporating user feedback and the online prediction of what that feedback will be, and the overall satisfaction of users, I think is a cool idea that could be very helpful even in a situation where you don't ask for feedback explicitly. Ryan says, the way Microsoft tried to fix it was they eventually had specific people authorized to retrain it live. I honestly don't like chatbots. I think the best we can reasonably do is have a database of stock responses and then doing intent classification that routes to those answers. Yeah, I think that's definitely a reasonable way of doing it. It's a little bit simplistic, but for systems that are interfaces to pretty simple things already, I think that could work. So my car renting example. I also used to really not like chatbots, and I have really grown to appreciate them more. Partly as, I was talking about this on Twitter, it's just something I've been thinking about a lot lately. Partially as an accessibility thing, because not everyone, a chatbot is just like an interface that uses natural language, right? So virtual assistants, things like that. Like Siri or Cortana or Google or Alexa, all of those sorts of systems. And for many people, that is much more accessible and much more doable than using a web interface, for example. I think especially as very technologically comfortable, digital natives, all of that stuff, we as data scientists tend to forget that that's a skill that takes time to learn, and not everyone has that skill. So they're really growing on me. And yes, yeah. I don't know. I think a lot of my sort of feelings about chatbots are changing quite a bit. It's just an interface, right? It's like any other type of interface design. You got to do it well, or it's not very usable. But it's just a different way of interacting with a computer. And it does make it feel like Star Trek, which is very nice. I do like that it feels like Star Trek. I quite like Star Trek, if you didn't know that about me. Yeah, so my biggest concerns with this system, I think that as a machine learning research question, it is interesting. I think it's good work. I personally would not be comfortable with deploying a system like this. Perhaps as like a training phase, if you had like a bot kindergarten where people knew that they were going to be helping a specific thing, or doing this through a crowd working service where people were paid for their time and labor. But I mean, the point of the point of the system is that it collecting data after deployment is cheaper is one of the things that they mentioned in the paper. Probably my favorite result from the paper is the nice intuitive result that the feedback itself was more helpful with smaller numbers of examples than the successful interactions, or obviously you need the human-human dialogue data set for the initial training, but adding the feedback on things that the model did wrong was especially impactful, and I like that, and I think it makes a lot of intuitive sense, and that's very satisfying. That feels like a nice result. I enjoyed that. All right, we got about 10 minutes. Let's pop down to this data collection, results as 10K candidates, comparisons and baselines, chatbot responses targets, the effective data freshness. So this is a system that is and isn't updated. Here's the regular expressions, trying to figure out what people weren't enjoying. Data collection, sample conversations. It's a lot of appendices. I think I'm most interested in D, which was about using the chatbot responses as targets. Anne says, I think this idea would work better for question answer systems. It could incorporate new information from users once it has done all the fact checking that we might be able to implement. Yeah, definitely. If there was you definitely need another layer of validation, data validation after data collection. I wouldn't just take the data and just like, flip, you're in the system now. Woohoo! All right, so D, using chatbot responses as targets. Both with few human-human dialogue examples, 20K, and many, 131K, adding examples with bot utterances as the target decreased quality. We explored using all bot responses, bot unfiltered, or BU, and only those responses with estimated satisfaction scores greater than 0.5. So you can see in both of these, just the human one had higher performance. Wow, much higher performance than adding the bot utterances. Interesting. Yeah, so especially when you are adding more bot utterances than human utterances, you get a precipitous drop. And there was you get a little bit of benefit from only using the filtered ones where you estimate a high satisfaction score, but it's still pretty minimal. We also considered whether it was possible to consistently identify really good responses by the chatbot rather than really bad ones. These could potentially be used as dialogue examples along with the ones that have human responses as targets, which we refer to as HH and HB in the paper. To explore this question, we modified our satisfaction data set so that the context with a rating of 5 were the positive classes, and ones with ratings of 1, 2, or 3 were the negative classes, discarding ratings of 4 to increase the separation between classes. The results were negative. Even with a training set of over 34K examples, the maximum precision we were able to achieve while maintaining at least 10% recall was 0.7, which is insufficient to improve performance on the dialogue task. Upon inspection, it appears that really good responses are hard to identify because most of the time they look like normal human-to-human conversation, and recognizing an appropriate next utterance is precisely the dialogue task we are trying to solve. It's hard to identify the good responses because they look like normal human stuff. And recognizing the appropriate next utterance is precisely the dialogue task we're trying to... That doesn't make sense to me. Negative responses, however, are much more semantically similar to one another, since most express one of few common ideas, such as asking for clarification or conveying confusion. Oh, these are responses from the human. Okay, so when it's a good dialogue interaction, the next response will be just like based on the previous response and just sort of follow the flow of conversation. When it's a bad interaction, the person's going to be like, what? Okay, gotcha. Ryan says, we had a discussion about this at the meetup a while ago. Would you consider Wolframalpha a chatbot? No, because I think for me to be a chatbot, it has to have multiple turns of interaction. So you have to have at least but. But it is, like, it's definitely a natural language interface. Yeah. Yeah, I think for me, for it to be a chat, I don't know, this is something I need to think more about. But I think for me, in order to consider it a good chatbot, I would want, it can't just be a question answering system. It has to have utility in some way. I have to be able to use it to accomplish a task, right? So Wolframalpha, I would say, would be similar to, like, I don't know, computer image generation, maybe? I'm trying to come up with something parallel. Yeah. Yeah, does Wolframalpha do intent mapping as well? It's been a while since I've used it. But I think it does mapping your query to a query that it can generate. I don't know that it does, like, more general purpose tracking over multiple things. Like, I don't think it does, like, anaphor resolution, which I would expect a bot to be able to do. So if I was like, how old is LeBron James? And then my second question was, how tall is he? I don't know that it would work. It might. All right, let's check it out. Wolframalpha, that's the one. Let's see if it'll do anaphor resolution. How old is, what did I say, LeBron James? I don't think that's how you spell LeBron. It might have an E. LeBron. Excellent. Okay. How tall is he? Yeah, no, it does not do. So I would expect a chatbot to have, like, a memory of previous conversations. Yeah, that's a really good question, because it's definitely a natural language interface, but it's not. I don't know. It's like a fancy search engine. It doesn't feel like a bot to me. Right. go back to the paper. We can start looking. We can look at a couple of conversations just to see what they look about. Do you like to go to the beach or the woods for a picnic? Good. Going to the doctor soon. I have some issue with my knees. That doesn't make sense. I think I messed up. You could have chose the beach or the woods the previous answer. Thanks. I'll try to remember that. Can you pick a new topic for us to talk about now? Because they discard all of this previous context. Do you travel? I want to go to Paris and make clothes. Wow, that's interesting. I've never been to Paris. I can see that. Do you like music? That's a little bit of a non sequitur. Oh, I can see you've never been to Paris. I love music. What's your favorite kind? Tell me more about you. That doesn't answer the question. You could have selected a type of music you like. Thanks, I'll try to remember that. Could you pick a new animal? Do you like animals? I have a dog. I like those too, but pizza is better. What? Oh, God, can you imagine trying to use this system? So this utterance doesn't make sense. This utterance is questionable, but the human didn't object to the point where the system asked for problems. This one's bad, and this one's bad. So that's a great interaction they have. Ryan says, but the majority of cases with Siri and Alexa and tools like that don't have great context memory either. Yeah, I think there's a difference between using a voice assistant as you would a search engine and using it to do a specific task, like skills. Just as an example, I know that on a Google account, I've got a Google Home. I have like a book that I'm listening to, an audiobook, and I can, on any of my devices, say, resume my book. And they know who I am, so they know what my is. Okay, I didn't say the wake word. I was like, every device in the room is going to be like, picking up where you left off. And I expect them to know what the book is, and I expect them to know where I am in the book. So there's additional context that feels more chatbot-y and feels more agenty to me than just like, how tall is LeBron James? Yeah. It's a good question. Like, what counts as a chatbot specifically? All right, one more conversation to round us off. Hopefully one that's slightly better. How about this one? Do you like dogs? I got a new puppy. I love being outside planting my plants. How about you? That's questionable. I love to plant too. Right now I have a beagle. She's a little feisty. I miss my shepherd mix. My dog is named Sam. He's a collie. Yeah, animals are my passion. I have 3, all big dogs. Beagles aren't a big dog. Yeah, I just have 1 dog and 2 cats. I do not. I take a lot of pictures. I'd like to be a famous photographer. I actually really want to get a picture of my animals with Santa, lol. Do you want to work out with me? What? This is not, like, it's kind of a conversation, but it's also kind of not. It's kind of like talking to a 6-year-old. That's a little generous. It's kind of like talking to a 4-year-old. And then this one triggers the thing. Like, this person is being like a great sport about this, but there's a lot of sort of like lack of internal consistency with the utterances. But I guess that's also not something they're targeting. It's not something they're modeling. But for chit chat in particular, I want that. Like, I want the number and type of dogs and their size to remain consistent throughout the conversation, because otherwise it feels, I don't know, it doesn't feel like a real conversation. Anyway, yeah, I think the thing that I like most from this paper is the estimation of the user satisfaction as a multitask learning auxiliary task in addition to the dialogue recommendation. So, interesting idea. I think it would need a lot of more work and a lot more, design review before I personally would be comfortable putting a system like this into production. All right. It is 10 o'clock where I am. I'm going to wrap it up here. I will be back on Friday with more live coding. I'm not 100% sure what we're going to be working on because it depends on how far I get on my own projects this week, but I will be sure to let you know. And yes, I don't think I have any other announcements. Thank you for joining, everybody. I hope you had a good time and enjoyed the paper. And I will put up a vote for our next paper. Also, I may or may not be streaming next week because I am out of town for a work event. And I definitely won't have my nice setup. So I'll announce it on the YouTube channel if I am or am not going to be here next week. All right. Lovely hanging out with you all today. I hope you learned something, and I will see you on Kaggle, and then back on Friday for live coding. I'll see you then. Bye.